All right, so we know that if q is a potential function for a, then the partial of q with respect to x is the I component, partial with respect to y is the j component, and partial with respect to z is the k component. So, because that's the gradient of q is equal to a. So we know this partial of q with respect to x is equal to this, to the I component. So we can just integrate that with respect to x. So integral of 6xy plus z cubed, that does not look like a 3, plus z cubed dx equals, so just integrate with respect to x. So that should be 3x squared y plus x z cubed plus c. We have a constant of integration. But in this case, since we just integrated with respect to x, and it's a whole thing of x, y, and z, we treated y and z as constants. So our constant in this case is going to be a function of y and z, and there could be a scalar added on, but we're not really looking for that right now. We just need the function of y and z. So this right here, this whole thing is actually equal to our q. We just have to find out specifically what this f of yz is. So we know that the partial, so since this is q itself, the partial with respect to y of this whole thing equals the j component. So we can integrate, or we can take the partial with respect to y of this actually. So let's do that. So partial with respect to y of that q equals 3x squared plus the partial with respect to y of whatever this f of y and z is. So since we know the j component is 3x squared minus z, this partial with respect to y has to equal minus c. So since that's the partial with respect to y, we can integrate that minus z with respect to y, and you get minus yz. So that minus yz is equal to the function of yz. We just calculated that. So so that's your q right there. So let's just add that on there, make it a new board up. So q equals 3x squared y, what was it, plus xz cubed plus our f of yz, which is going to be minus yz. And that could be our q. And we could have some scalar added on to, that would also be a potential function for a. But this is also a potential function without the scalar. So let's also verify that this is the potential function really quickly, or is a potential function. So let's take the gradient of q, and we should get a. So the gradient of this, so partial with respect to x, is going to give you 6xy plus z cubed in the I direction. And then partial with respect to y is going to give you plus 3x squared minus z in the j direction. And partial with respect to z is going to give you plus 3x z squared minus y in the k direction. And that equals a. So the gradient of q equals a, so q is a valid potential function for a, and that's your answer.